Hello everyone, my name is Anushka Luniya and today I am going to present on the topic vector similarity search and its evolution. This topic is one of the most exciting area in artificial intelligence and machine learning as it focuses on how machines find and understand relationship between data items not just through exact matches but through meaning and context. In this presentation, I will be covering several important aspects. First, introduction. What vector similarity search is all about. Second, need. What is the need of this vector similarity search? So why traditional search methods are no longer enough. Third, working principle. How it actually functions. Fourth, evolution and timeline. In this, we learn how this technology has evolved over time. Fifth, key algorithm. In this, we learn about the core model and techniques used. Sixth, application, where it's being used in the real world. Seventh, challenges and future scope, current problem and what's next. Eighth, will about and finally a brief summary of the key takeaways. Introduction to vector similarity search. Let's begin with the introduction. Vector similarity search, often called VSS, is a technique that helps computer find items that are similar in meaning or characteristic, not just in keywords. For example, in a normal keyword search, if you search for doctor, you will only get result with that exact word. But with vector similarity, the system can also find result like medical specialty because it understands semantic similarity. The key concept here is the vector, which is a numerical presentation of data. Anything, a word, a image, or even a piece of audio can be converted into a mathematical vector. Once converted, we can measure how close or similar two pieces of data are by comparing their vector. This technique powers modern AI system including images recognition, natural language processing, and recommendation engines. It helps machine go beyond simple keyword matching and actually understanding meaning. Now we learn about the growing need for vector similarity search. Now why do we need vector similarity search? There are three main reasons. First, beyond keywords matching, traditional search engines rely on exact keyword, which means they often miss results that are contextually relevant. For example, if I search for comfortable running shoes, a keyword based system might only look for page commenting those exact words, but vector based search can understand intent and find result like lightweight sneaker or sport shoes. which are symmetrically similar. Second, managing data diggers. We are living in a era of massive data from social media, sensors, IoT, interfaces, system. This data is multiple dimensional and unstructured. Vector search provide a scalable solution that can handle minerals or even billions of data points efficiency. Third, enhanced evaluation. By representing meaning in vector, we can achieve more accurate and personalized result, whether it's a product recommendation, an image match, or a chatbot response. This is whole about the growing need for vector similarity search. Now, working principle. Let's now understand how it's work. The core working principles. First, encoding. First, all the data item such as texts or images are converted into vector embedding. Each dimension in the vector represents a specific feature or attributes of the data. For instance, in text, one dimension might represent tone, another meaning, and another context. Second, indexing. These vectors are then stored in an efficient index structure that allow quick lookup and comparison. Third, querying. When a user makes a query, that query is also converted into vector. The system then look for the nearest vector is the database. Fourth, ranking. Finally, the system calculates how close each item's vector is to the query vector using metrics like cosine similarity and ranks the result accordingly. The closer the vector, the more similar the item. Now we learn about evolution and milestone. Vector similarity search did not appear overnight, it evolved gradually over decades. 1990s early models. This was when early vector space models were introduced for text retrieval. They laid the foundation for how we represent words as mathematical entities. 2000s data growth. As data explode, research bigger working on vector indexing techniques to make searches faster and scalable, especially with relational database. 2010s deep learning. Deep learning evolutionized everything. Neural network like CNN and RNN start generating rich, meaningful and embeddings. 2020s AI integration. How we were in the stage where AI driven hybrid search systems combine both keyword and vector search. These gives the best of both worlds, relevance, accuracy and scalability. Now we learn about core algorithm and models. Several important algorithm and model make vector similarity search possible. First, proximity nearest neighbors algorithm. They are designed to find the closest vector efficiently, even in the massive data set. Popular examples include HNSW, Hierarchical Navigable Small World, and FAISS, Facebook AI Similarity Search. They reduce search time while maintaining accuracy. Second, embedding models. These are responsible for converting raw data into meaningful vector. For text data, we commonly use Word2Vess. For image data, convolutionally neural network CNN. Third, hybrid search algorithm. These combine traditional keyword matching with vector search, giving highly context aware result. This hybrid approach is now widely used in systems like Google search and modern recommendation engines. Now we see applications of vector search. Vector similarity search has become a backbone of many industries. Let's look at some example. E-commerce, second knowledge management, third image search, fourth customer support. Now we see challenges and future. Even through this powerful, there are still some challenges and future opportunities. Curse of dimensionalities. When a vector have hundreds or thousands of dimensions, it becomes harder to process them efficiently without losing accuracy. Next, previous versus recall. Efficiencies versus recall. Balancing between finding highly relevant result and ensuring we didn't miss important ones remain strict. Emerging trends. We are seeing the rises of distributed and AI driven vector database to handle this issue. Now the summary. To summarize, vector similarity search has completely transferred how machines retrieve and understand data. We are evolved from simple keyword based matching to deep symmetric AI driven search system. It play a vital role in application ranging from image recognition and recommendation system to language understanding. As we move forward, integrating vectors such with large language models and real-time AI system will make our digital experience more personalized, accurate, and intelligent. Thank you for listening.